Assalamualaikum dear students, welcome to online support program. I hope you are all fine and enjoying online support program. I am Miss Arooba Farooq from EPSEX Gujranwala Cant with the lecture of week 6 of grade 6 science. As we have started this chapter in week 4 and week 5 and we still continues this chapter in week 6. Unit 3 Particles. Recap of week 5th. Before starting our today's lecture, let's have a recap of previous lecture. In previous weeks, most of the students, you have done a wonderful job. You have done your work very nicely and uploaded your assignments were very good. Well done, my students. Keep it up. In previous week, you have learnt about evidence for particle model, Brownian motion, diffusion, expansion and contraction. We have learned by some examples of evidence that particles exist or moving. Brownian motion is like a bee and diffusion is spreading of one substance through another. And when the things are heated, it means gets bigger, then they expand, and when they cool down they contract, and contract mean gets smaller, as you can see in the picture also. Now learning objectives week 6, pressure in gases, page 38, the Kulaspin can experiment, ideas for investigation on page 41, and new chapter unit 6, elements and compounds, introduction, page 70, what is an element, page 71 and 72. Now pressure in gases. Gas pressure is caused when gas particles hit the walls of their container. The more often the particles hit the walls and the faster they are moving. When they do this, the higher the pressure. This is why the pressure in a tire or balloon goes up when more air is pumped in. Now let's take an example of balloon. You can use gas pressure every time you blow up a balloon. Millions and millions of tiny air molecules are blown into the balloon with each breath. I repeat it, millions and millions of tiny air molecules are blown into the balloon with each breath. The molecules move around rapidly in all directions, bouncing off each other and the walls of the balloon. Each time a molecule hits the wall of the balloon, it gives the wall a tiny push. I repeat it. Each time a molecule hits the wall of the balloon, it gives the wall a tiny push. Millions of tiny pushes add up to one big push, the air pressure that inflates the balloon. Did you know the air pressure on you is roughly the same as the pressure on an armchair would be if an element sat on it? Now there are more examples about pressure in gases. Gas pressure keeps this car tire inflated. The higher above sea level you go, the lower the air pressure. Passenger aircraft have pressurized cabins to maintain the same air pressure throughout a flight. Now there is a question, how do we measure air pressure? So there is an instrument that is called barometer. A barometer is used to measure air pressure. Air pressure varies depending on weather conditions. A fall in pressure may mean that rain is on the way. Now there is an experiment, Kulaspin can experiment. Using the idea of particles, can you explain why the can collapsed? So, the collapsing can experiment. This can, as you can see before, this can is full of air and surrounded by air. The air pressure inside and outside the can is the same. This is why the can keeps its shape. And now, before the can is heated, particles are hitting the outside and inside with equal pressure. And you can see in the picture of after the can was heated and then cooled, there are almost no particles inside the can. So the pressure of the particles outside the can crushes it. I hope you will understand about the pressure in gases. Now, ideas for investigation. Investigate the speed of diffusion of a drop of ink in water. Put a spot of ink into a middle of a shallow dish of water. You will need a measure time and distance traveled as the ink particles diffuse outwards towards the edge of the dish. Use this formula to find the speed of diffusion. Speed is equal to distance over time. This investigation enables you to investigate diffusion in liquids. A dish of large diameter will make measurements easier. After a few minutes, students, you should be able to obtain the data to enable them to use the given formula to calculate the speed of diffusion, and the formula is here: speed equal to distance divided by time. I hope you can do very well. Now, assignment of week 6 of this topic, pressure in gases. Test yourself. Question number 1, how is gas pressure produced? Number 2, explain how air pressure keeps a balloon inflated. Number 3, when a balloon is inflated, where do you think the air pressure is highest, inside or outside? Explain your answer. I hope you will give answer very well now. Thank you. Next unit, that is unit 6, elements and compounds. We will start in the next video. Get ready, my dear students, for learn new concepts. Thank you.